This video is going to look at the one-to-one property, and the one-to-one property basically states here that if we have for an a value greater than 0 and a does not equal to 1, then a to the x equals a to the y if and only if x equals y. Okay, and again, I want to talk about if and only if. We've mentioned this before, but I want to kind of emphasize what this means. Basically, this means that we can read this statement forwards and backwards. So in other words, instead of writing this out, if a to the x equals a to the y, then x equals y. That's basically what this statement says this way, but the if and only if means we can read it the other way, which means if x equals y, then a to the x equals a to the y. So to save you from writing this statement both ways here, forwards and backwards, we can simply use this if and only if, and that means we could prove this either way. If we know a to the x equals a to the y, then we know x must equal y. Or if we know that x equals y, then a to the x will equal a to the y. So let's look at applying this one-to-one property to solve these exponential equations. So here we have a very simple one. If we have 2 to the x equals 2 to the 5, the thing what we want to indicate here is that we have the same base here, 2, just like in the statement up here. This is a, this is a. The base has to be the same. So what we're saying here is if 2 to the x is equal to 2 to the 5, then that tells us here that the exponents must be the same. So therefore, x must be equal to 5. And I think a little bit of logic and common sense would tell you that if these are equal, then x has to be equal to 5. Now, the next example we have here is 2 to the x equals 16. Well, notice now we don't have the same base. So here we have a base of 2, and over here we have a 16. So what we would like to do is make the base the same. So is there any way that we can change 16 so that it has a base of 2? All right, so if we do that, we could think of this as 2 to the x equals, if we make this a base 2, 2 to what power is going to give us 16? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16, so that would be 2 to the 4th. So now that we have the same base, then that tells us that the exponents are going to be equal, so therefore x must be equal to 4. And of course, we plug 4 in for x, we get 2 to the 4th, which is 16. All right, now one for a little bit more difficult. We have 1/2 to the x equals 8. So now we want to make the bases the same. Is there any way that we can write the base so that 8, we have 1/2 is equal to 8? Well, if we think of this as 1/2 to the x, well, we can think of 8 as being 2 to the 3rd power, can't we? 2 cubed is equal to 8. And if we were to use our negative exponents, okay, what if I made this here, and this is understood to be over 1. What if I move 2 to the 3rd to the bottom? If I move this to the bottom, wouldn't we have 1 over 2 to the negative 3? Now, I know this is kind of backwards of what we normally do. Normally, we want to make the exponent positive, but here we're trying to get a base of 1/2, so we're going to move this piece to the bottom, and if we move it to the bottom, we get a negative exponent. So we're close. We have 1/2 x equals 1 over 2 to the negative 3, but we can actually take this one step further, and we could really think of this as the same thing as 1/2 to the negative 3. And you got to be careful. This actually works because the numerator is a 1. So 1 to the negative 3 is still going to be 1. And then 2 to the negative 3 would have this 1 over 2 to the negative 3. So now we have the same base, 1/2 to the x, and over here we have 1/2 to the negative 3. So therefore the exponent must be the same. So therefore x equals a negative 3. Now be aware, not all equations of this type we'll be able to solve using this one-to-one property. This only works when you're able to rewrite the number that has the same base. Later on we'll look at how we can handle an equation where we're not able to write the numbers with the same base. So to realize that this is not going to work every time, but in certain situations it will work nicely. All right, here we have another example. E to the x equals e to the negative x plus 10. Well, once again, notice we have the same base here, e. So that means the exponents here, x must be equal to negative x plus 10. So now all we have to do is solve this equation for x. So if we add x to both sides, we would add x here, add x over here. So we would end up with 2x equals 10. And then we can divide by 2, so therefore x is equal to 5. So if we have e to the 5, that's going to be equal to e to the negative 5 plus 10, which would be e to the 5. All right, one last example, and maybe you can pause the video to see if you can work this on your own. Once again, we have the same base here of e. E to the x squared plus 8 equals e to the negative 6x. So that means x squared plus 8 must be equal to a negative 6 if these two quantities are going to be equal. Now here we have a quadratic, so in order to solve this we want to set this equation equal to 0. So I'm going to add the 6x to the left, so we would have x squared plus 6x plus 8 equals 0. And then of course with having a quadratic, our first step would be to see if we can factor, and if we can't factor we could use the quadratic formula. But here I believe we're going to be able to factor. X times x is x squared. And for the 8, it looks like we could use 4 times 2, and that would be a plus 4 and a plus 2. So we would simply take x plus 4 equal to 0, x plus 2 equal to 0. So therefore we get x equals a negative 4 and x equals a negative 2. So in this case we have two possibilities. If x is equal to a negative 4 or if x is equal to negative 2, these two quantities will be equal. Okay, so again, if we go back here to the one-to-one property, realize that as long as we have the same base, then that means your exponents here must be equal.